Hi, good morning. We are going to talk about an interesting section called 4.14. And we're going to be talking about the properties of rational numbers. If I can spell properties. Rational numbers. So we've been talking about a couple of these different sets and series of numbers. And let's quickly refresh our minds. We have the whole numbers. And that goes 0, 1, 2, 3, to infinity. We have the integers, which we've been talking about. And they go -2, -1, 0, 1, 2. Both ways to infinity. And now we're going to talk about these rational numbers. Now, rational numbers have an interesting trait. We can say that they are all numbers and in between these integers and whole numbers. And the way that we can define them is that we can use a ratio. A rational number can be written as a comparison between two numbers. And we call this comparison a ratio. For example, say that we have a class and there are 12 boys and 13 girls. We can write this ratio three ways. Three different styles. We can say we have 12 to 13, 12 to 13, or we can write it as a fraction. And these are all ratios, and they all describe a particular number. Now, this number is not a whole number. It's not an integer, because 12/13 does not fit on any of those things. And we can say that the rational numbers can all be described by a ratio like this. Now, there's a shortcut for writing these real numbers. So instead of for these rational numbers, I can also write a big R, a bold R, like this with two lines. And that kind of is going to refer to all of our rational numbers. Another way that I've called this is real numbers, which is very similar. In fact, they define the same set. So in this section, it's kind of interesting. All you're going to be doing is given a number, and you're going to need to describe that as a ratio between two numbers to prove that it's a rational number. For example, show that -20 is a rational number. Example 1. -20. Now, I need to show this as a ratio, and I'm going to write this as a fraction because that's easiest. And for me to do that, I can just write this, -20 over 1. Because that means 20 over 1 is just 20 with a negative in front. So I've shown that it is a ratio between two numbers, so I'm good. -20 is a rational number. Weird, right? Example 2. Take a look at this number, 0.85. Write this as a ratio between two numbers. We've been doing this because we've been writing them as fractions when we were taking decimals into fractions. I can write this as 85/100ths. Now, certainly I could simplify that, but in this case it doesn't matter because once I've shown that there's any ratio that describes that number, I'm good. I've shown it. And I know that, yes, this is a rational number. Let's talk about another number. Example 3. Let's take this number, 0.333 repeating. Oh, well, this can't possibly be a rational number. But in fact, I can. You probably recognize this number because it happens when you take a third on the calculator, when I do 1 divided by 3, right? So this I can write as a rational number of 1/3. These two are equivalent. Now this, of course, I can't enter into my calculator because I don't have enough digits on my calculator space, but I can enter 1/3. So this is a rational number. This would work. Let's try one more. Example 4. My space on here, pretty good. Let's take this number. This number is pi, and we spell it like this. And pi is a number, and if I were to write some of its digits out, it goes like this. It's approximately equal to 3.14159, and it goes on forever. Now, what's interesting about this number is it describes a comparison between parts of a circle, and there's actually no way that I can write this number out by comparing particular numbers. So pi is not a rational number. So in this case, I would not be able to explain it as a comparison between two things. There's not a lot of irrational numbers, because I could say that pi is irrational. But when they do come up, they are fairly interesting. The questions that you're going to be doing are mostly related to this. You're just going to be taking a number and you're going to be rewriting it as a fraction in any way that you can, using all the tricks and all the tips that we've been talking about so far. All right? Good luck.